Good morning, everyone. Nice to see you. Hope you're all well. And yep, my name is Stuart. I'm the ExamSolutions guy, and I'll be giving the live stream today. And as you most probably noticed, although I think it wasn't going that well, I just gave you a little clip where we're going to be looking at position vectors and vectors in general. Last time, some of you guys out there said that you'd like me to run through some vector work. So I've got some more vector work coming up later on this week. On Thursday, we'll be extending the vectors. So this is just a kind of brief roundup, okay? Now, while we're just waiting for people to come on, it's nice to see so many of you coming on. Thank you very much for showing your support here. And as always, it's great to have Michael from Air Maths Tuition on board. He's doing the live stream at the moment on the chat line, the live chat I should say. So welcome, Michael. Many of you might have seen his great video live stream yesterday. He's covering GCSE work, and he's again on tomorrow doing shapes and geometry. So I'm sure that's going to be a great one to watch. So we've got brothers and sisters out there. Do get them to come along, show your support. Okay, so yeah. Okay, so hopefully, as I say, you should have some paper. I want to get you involved in this, so do have a go, okay? I just want to encourage that, okay? So let's get started. It should take us about 35 minutes maybe to go through this, okay? 40 minutes. Right, okay, so let's just move across then, as usual, and I just want to give you a brief introduction, okay? I'm assuming that you're familiar with basic vectors, okay? Now there's an important result that crops up so often, okay? And I've just outlined it here. We're going to be meeting this throughout this live stream, and that is one of the things I always tend to notice when students are doing vector questions is that you don't draw diagrams, and I want to encourage you to do that. When we're dealing with 2 dimensions, 3 dimensions, okay, we're going to be looking at 3-dimensional vectors today. It's so easy for students, I find, to think, oh, I can't draw in 3 dimensions. You don't have to do that, okay, as I'm going to try and show you here. Okay, let's just imagine, though, that we've got the origin, O, and we've got points A and B. Now, when we talk about position vectors, these are vectors that come from the origin. So OA would be a position vector. O to B would be a position vector, okay? And if you sketch a diagram, it doesn't matter where you put your B and A. You could have B to the right of A, it doesn't really matter, below it. You're still going to get exactly the same as when you're going from A to B. When you're going from A to B, it is going to be A to O, followed by, that's the plus in vectors, O to B, okay? And what we do is we can reverse the A to O round by the negative law for vectors. This is the same as minus O to A when you're going in the other direction. So we get minus O to A plus O to B. And you could leave that result, but it's often written as O to B minus O to A. Okay, now say this is a common result, okay? So let's just put a question out there for you guys just to type in, okay? I know we can't write arrows over the vectors, okay? But if I said to you, you've got, say, a point P, okay, and a point Q. Suppose I wanted to get from, and I had the position vectors O to P and O to Q. Suppose I wanted to go from P to Q. Could you just quickly type in how we would go about finding P to Q? What would that standard result, based on this idea, what would it be? Going from P to Q. Just quickly type it in. Okay, we're looking for P to Q. What would it be? Okay, if you had those position vectors P to Q. Anybody? Okay, I just thought I'd throw this question in. P to Q is the same as going from O to Q minus O to P. That's right, okay, when you want to go from P to Q, okay, it's not P to O, okay, as Pooh has said, it's going from P to Q is O to Q minus O to P. Alright, let's just show you, okay. If you're going from A to B, right, all you need to do is think of it like this. You go from the origin to the last letter, in this case B, minus O to the first letter. So if you're going from P to Q, I would expect it to be O to the last letter, O to Q, minus O to the first letter, O to P. Alright? Okay, now you're going to need to know that result, alright, in the ones that are coming. Right, quickly moving on, alright, you should also be familiar with this result, okay, that the magnitude of a vector, if you've got a vector AB and it's got these components, as we say, x, y, z, okay, then the magnitude of the vector AB is the square root of the sum of the squares of the components, alright. It's basically working on Pythagoras' theorem. Now, I'm not really here to prove these results to you. I'm assuming, as I say, that you are familiar with these results. I just want to show you how we can use them in questions and get over this problem about 3D vectors when it comes to sketching. Okay, so let's just move on, okay? Nice easy question just to start off, basically. What we've got here is the points A and B have these position vectors. A is 1, minus 2, 5, and B is minus 3, minus 1, 2. Remember, they're position vectors. That means O to A is 1, minus 2, 5. Okay? O to B is minus 3, minus 1, 2. Find the exact length of the vector AB. Alright, so I'll leave that with you. Just tell me what that exact length is. There's a clue there, by the way. It does say exact length. So we'll just see who can come in with that exact length. Okay. Right, Ziggy's coming in with root 26. That's an exact value, but is it the exact value? Okay, is it the right answer? Okay, what about anybody else? Root 26 has already been put up there. Okay, square root of 26 coming in from all of you. That's it, great. So clearly you're on your way with that one. Now, I don't know, obviously, whether you drew a diagram for this, but it doesn't really matter. Here's our diagram anyway, okay? If I want to go from A to B, it's this standard result then. O to B, O to the last letter minus O to the first letter, okay? And all you need to do is substitute these vectors in, and you're then going to get this calculation in the usual way. Just simplify that by subtracting your components, okay? And you should get minus 4, 1, minus 3. And all we need to do now is use this result here. When it comes to the magnitude, okay, we just square these components. You'll notice, by the way, I've not written a negative 4 in here and a negative 3 in here. You don't have to do that. These lengths, really, the magnitude of something going negative 4 units is still a length of 4 units, okay, in what we would say the x direction. Okay, so you just have 4 squared, 1 squared plus 3, the 3 squared. Clean that up, and you've got the square root of 26. Notice, by the way, I've written units there. You don't have to do that, but I've mentioned this before, that when you're working out, say, an area of something, you would write square units, for instance. This is a length, I'm just writing units in there. It could be centimeters for all we know in another question. Okay, so just take care over that. And it's not plus or minus, it's just 26 positive value because it's a length. Okay, right, okay, let's just move on, okay, with this question now. Okay, right, it's going to get harder, progressively harder as we go through this. So I've got 2 whole questions to do. They've got several parts in them. Okay, so we've got this one now. Okay, it's the same question. I've just written up here that the length of AB is root 26 units. Now you've got to find the position vector of the midpoint of AB. And what I would encourage you to do is possibly draw a sketch for this. Okay, so just jot down a sketch. And when you feel that you've got the answer for the position vector of the midpoint of AB, just write that answer in. You can't write it obviously as a column vector, just give me the components, okay, the x, the y and the z component, and just separate them with commas, alright? So we're looking for that vector. It's a position vector, so remember it starts from the origin and it goes to the midpoint of AB. Okay. Good to see a lot of you still taking part here. Don't be afraid at all to put anything down. Well, not anything down, but have a go anyway. Okay, it's just good to see how many people are taking part here. Kieran's coming in with an answer: -1, -1.5 and 3.5. Anybody else? Okay. It's an interesting question, this, because I'm going to show you a couple of ways that you can do this. Alright, -1, -3/2 and 7/2, which is exactly the same obviously as the -1, -1.5 and 3.5. Okay, it looks good. It looks good that a lot of you are getting that answer. O to M is -1, -3/2 and 7/2. Okay, you can have it as decimal, okay, equivalent. So well done for taking part in that. I did say there's going to be 2 ways of doing this, and this might be quite interesting for you as an exercise later on. Anyway, I don't know if you did draw a diagram, but this is my diagram. Okay, it will still work out wherever you put your A's and B's relative to O. You should try it, okay, in different formats, okay, and you can check it. But anyway, I've just recapped with what we've got for the position vectors of OA and OB and the vector AB. So if you're going to find the midpoint, let's just put it on, okay, I've called it M. Let M be the midpoint of AB. So the way I would think most of you most probably tackled this was to say that O to M is the same as going from O to A followed by, which would be plus A to M. A to M being half of AB. Okay, so we can put that up as this result here. Okay, we knew what O to A, we knew what A to B was. It was this vector from the first part. Okay, so all we got to do is just substitute our column vectors in, and we would then get this result. Okay, and if we do half of -4, 1 minus 3, half of AB, that's going to be -2 and a half and -3/2, or -1.5. Okay, and group those vectors together and voila, you've got your answer. Okay, so well done to everyone who got that. Now, as I say, I did say there was 2 ways of doing this, and there is another way. Did anybody out there use the ratio theorem by any chance? Okay, just say yes if you did. Okay, obviously there's a bit of a delay here, so if you type in yes now, I won't see it until just about 30 seconds. Oh, right, Jasmine said I did. Okay, interesting, because it's a very quick and efficient way of doing this. Okay, And so I'd encourage you to learn it even if you didn't use it, okay? I'm going to give you this without any proof, okay, at the moment. It's a good exercise to try and prove it. The ratio theorem very quickly is this, that if you've got two position vectors, let's say OA and OB, all right, and you've got a point C on AB that divides AB in the ratio m to n. Okay, so C divides AB in the ratio m to n. That is, AC compared to CB is equal to that ratio m to n. And it can be shown, okay, I'll leave it to you if you want to prove it, okay, that O to C would be n times O to A plus n times O to B, all divided by n plus n. It's a very easy rule. Whatever this ratio is, you just do n times O to A plus m times O to B, and it's all divided by the sum of the ratio n and m. Okay, so how does that work here? Okay, very easy. Okay, by the ratio theorem, that ratio is 1 to 1 if m is the midpoint. So by this, it's got to be 1 times OA plus 1 times O to B, all divided by 2. I can pull the 2 out as a half, okay, and if you do that, you get half, and if you add those two position vectors together up here, you'll get -2, -3, 7, and if you halve them, there you go, you get exactly the same result. So the ratio theorem would be really useful to you if that was, say, split in the ratio 3 to 2, for instance, okay? Anyway, that's enough of this. I want to move on, okay? So let's just show you the next part. Now, this next one, okay, it's part 3 of this question. So we still got our points A and B with these position vectors, and we introduced 2 new points with P and Q with position vectors 1, 2, 0 and 5, 1, 3 respectively. And we've got to show that AB, PQ is a parallelogram. Now, what I would like to do here, okay, it's a showing question, and obviously it's a bit different when we're doing a live stream, okay, to do these kind of showing questions. But I just thought we'll do it in this way, okay? Let's say we sketch the parallelogram. You've got to sketch the parallelogram, all right? So if I sketch the parallelogram, remember that your letters, when you sketch a shape, should follow one another around, okay? You'll see I've got A, B, P, Q here, and I've got my origin here. Just put O. I can put it anywhere I like. And this is the point, by the way, that when we're dealing with 3-dimensional vectors, we don't have to set up Cartesian axes, okay? We just sketch a diagram, okay? Just sketch a diagram. And your origin, okay, anywhere, it doesn't matter. You'll still get this, exactly the same results, okay? Now, what I'd like to ask you, okay, is if we're going to show that this is a parallelogram, okay, what do you think we would need to do, okay? What do you think we would need to prove, okay? Let's throw this open. I don't know how this is going to go. Just type in what you would think that we would need to ultimately show, okay? Let's just throw it open, okay? Just type in what you think very quickly you ought to show. We've got Ziggy coming in with B minus P, okay? B minus P should be equal to A minus Q. Interesting result there, Ziggy, okay? Gradients and length of opposite sides from Gary. I'm thinking saying that they are got to be exactly the same, maybe. Find the lengths of AB, PQ. Show that they're equal. Interesting result there from Kumaresh. Okay. Ziggy, they would be parallel, I mean. Okay. Alright. Prove that QP and AB are parallel and PB and QA are parallel. Good answer. Okay. Good answer there from Adam. Alright. I like that one. Let me explain why, okay? I see quite a lot of you thinking, right, okay, let's just show that an opposite pair are parallel, okay? Or let's say we for instance, try and show that QP is parallel and the same length as AB, okay? In other words, we'll work out those two vectors, Q to P and A to B, and if they're the same, is that going to mean that they are, that will be a parallelogram? Well, the answer is no. Okay, it might surprise you on that. You can't guarantee that. You can see it might be the case if we've got this diagram sketched here, but if we took away that diagram, okay, we could get a situation like this. Okay, I'll just see if I can draw it on. Okay, whoops, that's not the right one. Okay, just bear with me for a moment. Yeah, if we were to put this on, if we were to show that QP was exactly the same as the vector AB, it would show that they're parallel. It would show that they're the same length. But who's to say that they weren't in the same straight line? Okay? So it's not sufficient just to show that we have two vectors which are equivalent to one another. Okay? We've got to also show that the other pair, okay, are parallel and equal, that they're the same. So in other words, this is what we would have to show, that QP was equal to the vector AB and QA was equal to the vector PB. Okay? Mind you, we could have PQ being the same as B to A. Okay? That doesn't make any odds. Okay? You can have them go, as long as they go in the same direction. Okay? So, that was the important bit here that I wanted to put across, okay? That we are trying to show that opposite pairs are parallel and equal in length, all right? Now, let's just wind this up very quickly. As I said, I wasn't too sure how this was going to go, but let's just say, let's just throw it out there. Some of you guys go for QP, go for AB, and others go for QE and PB. Okay, just tell us what you make each one. Okay, it doesn't matter which one you pick. Some of you go for QP and say QP equals. Some of you go for AB, say what that equals. Others do QA, and some of you out there do PB. Okay, just give that answer. Okay. Don't have to work them all out, just quickly throw them up, okay? And then we can move on to the last question. Okay. Anybody got anything for QP or AB or Q to A, P to B yet? Remember that result I was trying to say to you at the beginning when you want to go from one point to another via the origin? Q to P, we've got Kumesh. Q to P, she says, says it's -413. So that's interesting. Let's see what we get for A to B. A to B, -4, 1, -3. Now that's very interesting. Do you notice how we're getting a different answer there? Okay. Okay, Kieran. Sorry, it was a 3. Okay. Anyway, interesting answers coming in. We've got Q to P, 4, 1, -3. Okay. Adam with -4, 1, 3. This is really proving quite interesting. Okay, so with all these things flashing by, I'm finding it hard just to keep on track who's given me the right answer. But it does seem we're getting some differing answers here. Anybody coming? Oh, we've got PB coming in there. All right. Okay, well look, you can see there's some answers coming in, and to be honest, trying to keep one eye on the what I'm doing here and one eye on the live chat, it's a bit hard. Okay, I'm relying on Michael out there maybe to spot what's going on. Anyway, look, let us go through this. Okay, if I had to work out Q to P, this standard result again, O to P, O to the last letter, okay, the origin to the last letter here, minus the origin to the first letter. And all you've got to do then is just put in your column vectors that we have up here, subtract them, and you get Q to P is -4, 1 minus 3. All right? Q to P is that one there. So I've got to find out what A to B is. And easy, right? I'm not going to show all the sections now. A to B is O to B minus O to A. Standard result. Substitute your values in, okay, up here, and you notice we get exactly the same. All right. Obviously, if you've done P to Q, do B to A, and you would have found that you'd have got negative of this result, okay? So that would still be fine. But it's not sufficient, as I tried to point out here, okay? A point that can be missed. So what I'm going to do is work out Q to A and P to B. And if you do that in the same way, okay, by subtracting our vectors, getting this standard result going, what do we end up with? Both of those come out at -4, -3, 2. Okay? So what do we say? We need to put a conclusion in there, and this is my conclusion. Since we've seen that QP is equal to AB and QA is equal to PB, it's basically telling us that therefore the opposite sides are parallel and equal length, okay? So, therefore, don't forget to say that you've proved then that AB PQ is a parallelogram, all right? So, what am I trying to show you? I'm trying to show you not to be scared of just drawing a shape in when we're working 3 dimensions. You don't need any coordinate axes or anything like that. You need to know these standard results, okay? And just take care on a question like this. All right, okay, let's move on now. Our last question, okay? It's got 2 parts to it. First part is very quick and easy. And let's bring that up. Okay, in this question, okay, we've got position vectors for points A and B. Put them down here, position vector of A, position vector of B. Just in case you can't see these, this is -3, 2, 7, and O to B is 3 minus 1p. P is a constant. And we've got these other vectors. B to C is 0, 6 minus 7, and A to D is 2, 5 minus 4. And you've got to find the position vector of the point D. So again, this one should be fairly quick, okay? So just leave you loose on this one, okay? So you can come in quickly with the answer for the position vector of D. That is, in other words, going from the origin to the point D. Okay, it's good to see many of you sticking with this. Okay. Remember, if you don't understand any of this stuff, you might want to go back. Once the live stream's finished, it becomes it's just put up automatically as a normal video, so you can pause it at any point. All right. Okay, so we see my answers coming in now for O to D, -7, 3, -173, -1,733 from Ziggy. I think that might have been, I think you might have got that, Ziggy. I think you just tripped up there, because it is -173. Well done to everyone. Did you draw a diagram? I don't know, but that would be something like I would draw if I wanted to draw a diagram for this. Okay, just draw my point A anywhere I like, point D anywhere I like. I want to go from O to D, and I'm going to go from O to A, followed by, which will be plus the vector A to D, because I have it up here. Okay, so I've just got to add these two vectors together, and setting it out like that. Okay, O to D, that familiar result again, is O to A, followed by A to D. Okay, all right, I said familiar result, sorry, it's forget what I just said there. Okay, I'm using triangle. All right, I'm just panicking. Okay, so write that in column vector, just fill in your vectors. There we go. Right. And add them together, and you got -173. All right, okay. Going back to that slight mistake I made there when I said using the standard result, okay, if I wanted O to D, my immediate thought might have been, oh, I can get O to D straight away. Is it up here? No, it's not. Okay, so I had to look for a different way of getting there. All right, okay, right, now this is the question that I really want, I think is really interesting, okay, this next bit coming up. So I hope you're ready for this, okay. Right, question 2b here. Now we've got to take it, I'm going to take this in little steps, okay? We're told here that given ABCD is a trapezium, we've got to find the value of P, this value P here. Now, I'm sure some of you might carry on and just work this out. That'd be great, okay? But I do want to encourage you to think about drawing your trapezium, okay? So before you go racing ahead, can I just get you to, on a scrap of paper, okay, just draw out what you think that trapezium would look like, okay? And just say done when you have drawn your trapezium, okay? This will be interesting. Just draw your trapezium and just tell us when you're done. Okay, so I'm looking for that trapezium. Okay, good. We're seeing some of you had a go, just saying that you've sketched it. Okay, obviously we most probably all done different drawings, okay? All done different drawings. And I want to kind of show you that it doesn't really matter as well, okay, to a certain extent. Okay, right. Now, I don't know what you have drawn, okay? When you draw a trapezium, I'm assuming you're familiar with trapeziums, shaped with just with a pair of opposite sides parallel. Okay, now you could have drawn maybe a trapezium something like along these lines. Okay, just tell me if you did draw a trapezium like this, having AD and BC parallel. Okay, could you just say yes if you did do that? Okay, if you thought that AD and BC were parallel. All right, just say yes if you did. Okay, Adam says he did. Okay, what about anybody else? Okay, saying that you put AD and BC parallel. Did it even cross your mind? Okay, good. Okay, then you're wrong. Kind of a trick question there. Okay, now, are AD and BC parallel? Okay, have a look at these vectors. What makes parallel vectors? Okay, we would expect to see one as being a multiple of the other. Right, and when I look at AD compared with BC, just take this 0 for instance. It's the easiest number to work with. Okay, what do I times 0 with to get 2? Ooh, there isn't a value. Because if there was, okay, I would expect to multiply each of these numbers by a constant value. Okay, suppose BC were to be twice the length, say, of AD. I would expect to see this vector AD to be twice BC. Sorry, no, I've got that wrong, haven't I? If I said BC was twice the length of AD, okay, I would expect to double this, for instance, and see a vector here saying 4, 10, minus 8. All right? These two vectors are not multiples of one another. So they're not parallel. Okay? So, how many of you, if you're honest, drew a trapezium where you had AB being parallel to DC. Okay, be honest, okay, just out of interest. It doesn't matter really, but just tell me if you did see that, okay? Just say, yeah, I did, or something, I did see that, okay? Just be interesting, all right? Okay, you can cheat, go on, you can cheat. You can all say, I did, I did. I don't know, but I just want you to be aware of that, okay? Right, okay, so where are we going with this? Okay, it is not that trapezium, that first trapezium. That is because the vector AD, for instance, is not a multiple. I've called that multiple K. It's not a multiple of the vector BC. Okay, so you've got to watch out for that. Okay. Okay, guys. All right, just having a bit of fun here. All right. Okay. It doesn't matter if you got it wrong. Okay. I just want you to be sure that you've understood why. Okay. That's all. So this is what we're working with. Okay. And this is the key point here. I don't know at this stage whether AB is longer than DC. I've just made a sketch. Okay. I just want to make sure that we're trying to show this as a trapezium. So where are we going to go with this then? Okay, what we need to do, if you haven't guessed already, some of you might be starting to work ahead. If any of you are, just type in your value for P, okay? I will guide you through this, okay? What we're going to need to do is work out the vector AB, the vector DC, okay? And we're going to compare them. We would expect them to be a multiple of one another, okay? So see if you can get those vectors A to B and D to C. That would be a good start, okay? What about that? Okay, if you haven't come up with P already, just type in when you've got A to B and D to C, all right? And we'll take it from there. So you should be using those that classic result that I was introduced you to when you want to go from A to B and when you want to go from D to C. How do we do it via the origin? So anybody got A to B or D to C? Let's see what you get. A to B should be quick. You can give it in terms of P. It will be in terms of P if you get A to B. D to C should be a good one to go for. Okay, we've got Bushy coming in with A to B is 6, 3 minus P. Anybody else going to offer up anything? A to B. Okay, taken about 40 minutes on this so far, okay, on this live stream. We'll be there very shortly, okay, if you can just stick with us on this. As I say, the interesting thing is you know, just having sketches is important. Anyone else got anything to offer on A to B? Or D to C. I'm going to have to run through this in a minute. Okay, Bushy, A to B is now 6, 3, 7 minus P. Okay, A to B from Adam is 6 minus 3, P minus 7. Okay, interesting results. Okay. Right, I'm going to have to move on, all right, because there's some of you guys out there might be just waiting for this to move on. Okay, well, you're getting there. Okay, let's just run through this, okay? Let's go for A to B, all right? Since a lot of you are giving me that answer quickly, okay? So I'm going to look at A to B, okay? A to B is going to be O to B minus O to A, okay? So just got to do this subtraction, okay? So if you do that subtraction, write down your column vectors, you're going to end up with 6 minus 3 and p minus 7. Okay, so I can see, I think, Adam, did you get that one? I think you did. Okay. So, and I'm sure some of you others out there got that one. Okay, so good, Ziggy, I can see got that one as well. That's A to B. What about D to C? A little bit more involved. Anyone out there got D to C? Just type in D to C if you got that. Bit harder. Okay, D to C. Remember, you've got O to D down in the previous result. Okay. Ziggy's coming in with an answer, 4, minus 2 and p minus 10. Okay. Good. Pooh's working on it. Good for you, Pooh. Well done. Great to see that you're working on this. That's good. 4 minus 2, p minus 10 from Adam. Good. This is really good. Okay. So we'll just put this up. Okay. I was going to do this first, as you can see. Okay. D to C was O to C minus O to D. That classic result again. Okay. I put the origin in just so you can check it out again. All right, if you wish. All right. Now, let's have a look at this. O to C. Okay. If we want to look at this, we can see that let's have a look. Yeah, O to C, okay, is going to be O to B followed by B to C. Okay, you got to see that, and then we got minus O to D. And we can fill in our vectors, column vectors now, and if you fill those in for O to B, B to C and O to D, then you should have this. And cleaning this up is going to give you, whoops, okay, wrong line. Okay, going to give this result, 4, negative 2, p minus 10. So well done. I can see that a lot of you got that. Now, how do we work out what p is? I can see actually someone's coming in with p, okay, as 16 over 5. No, minus 16 over 5 from Kumaresh. Let's see, has anybody else got a value for p? Where do we go from here if we know that these are parallel? Think about that. Think about this idea up here that I put. Okay, if two vectors are parallel, you would expect one to be a multiple of the other. All right. Okay. So is anybody else out there working ahead and able to try and figure out what p is? Kumaresh says p is minus 16 over 5. Who knows? Might be the right answer, might not be. We need more up there. Go for it. Go for it. Din coming in with p equals 16, differing from Kumaresh. All right, so either one of you's right or both of you are wrong. Who's it going to be? Anybody else? God, I'm on the edge of my seat here in anticipation. Ah, we got Bushy with 16 over 5. Interesting. So, 3 differing answers. Ah, Ziggy, p was 16. Possibly p does equal 16. Who knows? All right. One more. Let's have one more coming in. Okay. Kultar, 16 over 5. So, okay. David with 16. It is 16. Well done for you guys who got 16. Right, let's quickly take you through this last bit, okay, and then we'll be finished. Look, DC is a multiple of the vector AB. I've called it lambda, okay? It doesn't matter whether DC is longer or shorter, okay? If DC was longer, I would expect lambda to be a number greater than 1. If DC is shorter than AB, I'd expect lambda to be less than 1, okay? But greater than 0, obviously it can't be a negative value. Okay, let's have a look, see what happens. We put down, that's our equation. Let's sub in our column vectors. Should have something like this, okay? Then, all I need to do is, because they're equal to one another, I can say that the components must be equal. 4 must equal 6 lambda, or minus 2 would equal minus 3 lambda, or p minus 10 must equal lambda times p minus 7, okay? I'm going to go for the middle one. It looks the easiest to work out what lambda is. Minus 2 equals minus 3 lambda. That's up to you. You could get, if you looked at the top row here, 4 equals 6 lambda. You're still going to end up with the same value for lambda. I'm choosing the middle row. Minus 2 equals minus 3 lambda. And if you rearrange that, lambda equals 2/3. Okay, so DC is 2/3 the length of AB. Okay, who cares? We drew the wrong diagram there. It doesn't matter, but we did figure out that they were parallel, all right? All I need to do is look at the bottom row. Substitute in the bottom row my value for lambda. I got this equation now. Multiply through by 3 to get rid of that fraction. You should get this result here, okay? And then just rearrange it, and bingo, p equals 16, all right? So, quite a lot of variety, I hope, there for you guys, okay? Do come back on that, okay? And review it later on if you're stuck, okay, at any time. So, that leaves me to come on now, okay? So, hope you did well on that, and great to have so many of you on and supporting this, these live streams. I do listen to what you're saying. Obviously I can't do everything, okay? Last time a lot of you guys requested vectors. That was the most popular request that I got. I will be doing more vector work this coming Thursday, and I hope that I can design questions for you that are going to be beneficial in the time that we've got. If you enjoyed this, please, and got some value from it, please give us a thumbs up, and in the description below, okay? And do subscribe to my channel. If you do, ExamSolutions channel, it will just mean that you'll get notifications of when we're going to have these live streams, okay? And you'll get links to them. So, leaves me to wish you well, stay safe. Thank you very much to Michael, as always, Michael from Air Maths Tuition. Don't forget, he's on tomorrow. Great session, I'm sure he's going to be bringing you. And hopefully tell your younger brothers, sisters, if you have them, to come along. And even you might like to come along and give a warm welcome to Michael. It will be his second live stream, so it would be great to have him on. Okay, so see you guys. Have a great day. Hopefully see you tomorrow. If not, the following day, Thursday. Okay, see you for now. Bye.